Hello, friends. Today we are diving into a project that is an optical illusion created by vibrations in this chain. It is called the ball chain spinner. And for anybody who is not aware, the chain that comes with this project is actually called a ball chain. Maybe you can see why. So this chain is strong and rigid. It's attached to these two pieces of wood that we have here, paint stirrers. And when we stretch out the ball chain, we create a vibration along the length of the chain. And that vibration, which is a quick back and forth movement, I like to make the kids do this with their hands, a vibration anytime I say that word. So that vibration, that quick back and forth movement of the chain inside of this hole in the cutout makes the chain bump against the inside of this hole. And every one of those little bumps or pushes as that chain is vibrating actually helps to push this cutout and spin it. So every time we pull on this chain and straighten it out quickly, it creates that vibration, which is that little push, that little force inside of the hole in our cutout. And it causes our cutout to spin. And it actually spins pretty quickly. And because the cutout is spinning at such a high speed, that's what creates an optical illusion. Optical meaning eye, an illusion meaning trick. So an optical illusion is a trick of the eye. The speed with which this vibration happens, creating a quick and fast spin on our paper cutout, is the reason why we get this optical illusion. If I'm letting you look at this piece of paper when it's still, you can perceive all of these individual stars as stars. If I turn this paper slowly, they may be a little bit blurry, but you can still perceive that these are stars. And that's because I'm not spinning this paper so that you're seeing more of these stars within your vision and within your eye than you're able to in 1/16 of a second. If I spin it really quickly, though, your eyes are going to combine all of these star images into one. So one star is going to persist in your vision, and it's going to kind of mix with all these others, and it's going to make a continuous line. So when my project spins, all of my stars just turn into a pink circle. And this blue wavy line, which I see as a wavy line right now, just turns into a solid blue line when my picture is spinning here. So persistence of vision is basically when one object or one image persists in our brain, and specifically, actually, it's persisting in our optic nerve and in our brain for longer than 1/16 of a second, and it means images are combined. So we talk about this in our science note. Persistence of vision is a response of our visual system. So our visual system is an eye-brain connection. It takes our eyes and our brains to allow us to see. So I've drawn that here on this piece of paper. And if we have one image that's shown to our eyes, see the red envelope here, this message being passed along was already shown to my eye earlier. So the red image was shown to my eye and it's being passed down the optic nerve all the way to the brain, right? And the red image, the red message hasn't quite reached my brain yet. So my brain hasn't perceived this information. So before the red message gets to my brain, I also show my eyes this blue message. And that is passed through my eye, down the optic nerve, and into the brain. And just as the red message is reaching my brain, the blue message is already in transit, and it is also reaching my brain. And my brain can no longer separate the time between when that red image came in as red and the blue image as blue. So it combines those two images and tells me that I've only seen the combination of the two things. And in this case, these are different colors, and the combination of these two colors is purple. So if I show my eye within 1/16 of a second, this red envelope, and then within another 16th of a second, I show it the blue envelope. Remember, it has to be quick. We can see 12 images per second. So if I show my eye these two things within these 12 images back and forth within 12 seconds, or within 1 second, these 12 images within 1 second, then my brain will tell me I've seen the combination of those things. So that's why we say in your science note that you can actually do pie wedges of different primary colors. And I have the information right down here as to what primary colors equal what secondary color, so that you can share that with the kiddos. And your brain will do some color blending or color addition here. And because of persistence of vision, those two images are going to combine in your brain, and those two colors are going to combine in your brain to show you this secondary color once this is in motion. All right, so optical illusion, a trick of the eye, persistence of vision. Our eyes and our brains work together to allow us to see, but we can trick our brains if we show our eye multiple images within 1 second. So if we show our eye 12 images or 12 sections of color within 1 second, then it's too much information for our brain to separate out, and our brain's instead going to combine all of the information, and it's going to tell us that we have seen the color green instead of blue, yellow, or it's going to tell us that we have seen a blue line instead of a wavy line, and that we've seen a solid pink circle instead of single stars like we have here on our image. Okay, we also give you a cutout. That's what I've drawn on the back of. And you can have kids put one cutout on their spinner here, or even try 2, try 3, try experimenting with different things in class and see what cool optical illusions you can create based on the ball chain spinner and the vibrations from that ball chain making our project cutout spin around and around. You do have to hold this horizontally. You can't hold it vertically. If I hold it up here and try to pull on this, see, it's not spinning. If I hold it horizontally and collapse the ball chain and then pull out on these two pieces, then it creates those little vibrations. Those vibrations are little pushes on the inside of the hole. And that means that my project cutout is going to spin round and round. So this is very simple to build. You're going to put the ball chain through the hole. On the other side, you're going to put a piece of masking tape, wrap that masking tape around and press it down over the ball chain really well. You do cut your cutout out first and then color on the back side before you build this contraption. But there are a couple little things that could go wrong, even though this project is really simple. And those are the things I really want to focus on showing you how to fix today. One thing that could go wrong is a kid comes up to you and says, hey, I really almost ripped the center of my cutout on my ball chain earlier. But I really drew some cool things on here and I don't want to get rid of this. Can you help me fix it? So if the ball chain is getting stuck in like a groove, like I have right over here in this hole, then you can take a piece of Scotch tape. See how I have a hole in the Scotch tape? And you can take your hole punch out of your scissor bin, put a hole punch through that Scotch tape, and then put the Scotch tape over top of the hole in the project. So the Scotch tape is clear. It's now over top of this hole and it's reinforcing it. And then you're going to do the exact same thing on the other side. So take a little section of tape, Scotch tape specifically, not masking tape, put your hole punch on it, punch the hole, take the hole punch off, rip the piece of tape off, go to the other side, overlap the Scotch tape on the hole in the location where it's supposed to be, rub it down really well so it still shows their beautiful decorations and colors through it. And now you have a reinforced hole for this project so that the vibrations are still going to push this circle round and round and not get stuck in one spot because of that paper being ripped. Now, the other thing that's a little bit tricky with this project is that the holes drilled in the center of your paint stirrer here might be a little too small for you to put this dowel through. And that's the first step of your project once you start assembly, right? So this slid right through here just now, but that's only because I've enlarged this hole and I'm going to show you how. Take a pair of scissors and open them up. Take that pair of scissors and put it through, push it through the hole as far as you can, and then spin it around. Take it out, flip your paint stirrer over, put the scissors through the hole and spin it around. Before I did that, this dowel would not fit through this hole, and now it does fit through there. It's still snug, that's what we want, but it's loose enough that it actually gets it through the hole. And sometimes if your kids are struggling in class, that's what you will need to walk around and do to make sure this project can actually be built by everyone. Now you take this little disc and you press it onto the end. You do want this to be tighter because you don't want the whole assembly to come off. So you may need to lay this on the table flat and then press the dowel down into it. All right. This may be something that the teachers have to walk around and help with a little bit. Now that that's done, remember pushing and twisting is also the key to a lot of these types of things. If you can't push straight down on it, then you might have to push, twist, and that will push things together. Now that this is assembled, you're going to drop one end of the ball chain through the hole. Once it's dropped through the hole, you only need about 5 balls worth sticking through here. Take a piece of masking tape, press it down over it, squeeze it around the balls really tightly so that they don't slide out, because you're putting a lot of pressure on this as you pull these craft sticks apart. Now that we've assembled this side, we're going to drop our cutout on, take the other end of the ball chain, put it through the hole here, count 5 of those ball chains out as sticking through the other side to make sure it's overlapping well, and then tape it down again. And once we've done that, we have assembled our project. Optical illusions are a trick of the eye. It requires an eye-brain connection to allow us to see. Persistence of vision is a phenomenon by which our brains combine multiple images or colors because the speed with which we showed those images or colors to our eyes was too quick for our brains to keep separated. So it combined those things into one. All right, and a vibration. Have your kids silent clapping, quick back and forth motions. Have fun. I hope this project is a delight in class, and maybe your kids will be vibrating with happiness and excitement to be able to finish this project. Enjoy.